Howdy, I'm Kelly and I'm part of Team 19 along with my teammates Alfonso and Paul.
Overview. This DSTR robotics-based project was designed with the central theme of systems in mind. It brought together simple systems that work together to perform as one system of systems. The microcontroller, H-bridge, motors, body, and code all came together to perform as one action as one DSTR robot. Alfonso and I worked on the control team, while Kelly worked on the mechanical system. There was a lot of crossover between the two.
So, the mechanical progress. The first time we met together as a team to work on the project was at the EIC, where we followed the online instructions as to how to cut the legs and rods that were going to be used in the future. We used a table saw to cut the metal rods and bars in the appropriate spots and used a drill to make holes through the metal bars. Again, we followed instructions given to us and put together the rods and the 3 printed parts provided. How we completed the DSTR body was, again, we followed the provided instructions to assemble the body. We put together the robot legs with the body constructed in step 2 and added metal bars to help keep the structural integrity of the robot. Throughout the assembling, we would tighten the parts together. In the end, we added the motors to the end of the legs and connected the sled to the part built in step 2. The wires connected to the motors were put through the legs and were pulled out through the drill hole in order to connect to the H-bridge. Mechanical learned. The first thing we learned was how to read and follow instructions. In order to build the robot, we had to connect the information and pictures provided with the materials and the tools we had at hand. The second thing we learned was how to adjust the situation. When we were testing the robot's mobility, we would test how agile the body was. If it wasn't to our desire, then we would tighten and retighten the areas we thought would optimize the performance of the robot. The third thing we learned was how to coordinate with the control group. While building, we realized that the best way for the robot to have mobility is if we adjusted the sled so that it won't bump into the bar that controlled the front legs. So we used a heat gun to shape the sled to our needs. The fourth thing was build with the end result in mind. When it came to putting the whole robot together, we had to coordinate with one another in order to have the best possible mobile robot.
Control progress. Our first task as a control team was to build the sled. We first started off by marking the material to be able to cut it. Once it was cut, we used a heat gun to shape it to be able to fit the body of the car. Then we learned how to solder 2 wires together and how to tint wires, which was a vital part throughout the project. When it was time to implement the motors, we first started off by testing the polarization of the motors, then proceeded to solder them together with beam extensions. Afterwards, we connected both the batteries and the motors to the H-bridge and finished off by connecting the H-bridge to the launch pad. Control learned. Again, one of the most important things we learned was how to solder wires together and how to tint the wires. We also learned how to place the wiring the most efficient way, so they wouldn't bother us or interfere with our performance. When it came to combining the mechanical side, we had to coordinate with them to be able to finish the project in the most efficient and productive way. Coding was something we had to plan and test for. Since the motors didn't turn with the same speed, we had to make alterations to accommodate our needs.
Current status. Thus far, we've constructed the DSTR body, wired the launch pad, H-bridge, and motors, coded the launch pad, and tested the final system. Upon initial testing, we learned that it would be in our best interest to use a single joystick control unit for more control of the robot. Since then, we've moved on to the testing phase of the project. We are updating some of the DSTR robot's wiring and implementing new code that will ultimately give us feedback in the form of a data structure. This will allow us to evaluate performance of our DSTR robotic system. Next, we will show you a video of our working DSTR robot.
Okay. Clear the aisles. Not standing unless your team is ready, please.
Alright, this was our first demo with a functional DSTR robot. Our task was to drive from one end of the classroom to the other in the shortest amount of time possible. In this particular video, our robot completed this task in 10.89 seconds. Thanks for watching.